Hello and welcome to AZ-900 Microsoft Azure Fundamentals Training Series. This is the second learning module, the cloud benefits. We'll demystify various concepts like high availability, the scalability, the reliability, and predictability. We cannot discuss cloud concepts without talking about the security and governance in the cloud. Then we will finish with how to manage all of this. Stay to the end of the video as I will give you a lot of real world scenarios to illustrate these concepts for you, and we will have some knowledge check at the end. My name is Bilel MAROUEN. I'm Azure Solutions Architect and Microsoft Certified Trainer since 2017. I'm glad to be your trainer in this journey into the world of cloud computing with Azure. First step, let's talk about the high availability. I believe that everyone knows the frustration when you cannot navigate to a website to book a flight or to buy something during the sales period, for example, or just to register for a famous event. Frustrating, right? But in the business world, this downtime can mean loss of revenue and unhappy customers. Let's switch to the slides and give you some examples. With Azure's cloud service, high availability is built in. So here we have a client that is trying to reach his application, and we have two instances. As in the Azure, we can put different instances in different data centers or availability zones or different regions. To achieve the same in traditional IT setup, we need to buy more materials to install these servers in different locations to have redundancy in your data layer, your access, your application layer. So we need to multiply everything. This will be multiplying the overhead to maintain this platform for patching, monitoring, security, and everything. So having the same premises, this will have more cost, more investments, and more overhead. However, in the cloud, this is like built-in feature that we can deploy and consider when we design our application. So redundancy will be built in the cloud and for almost no cost. As as I explained, we have multiple regions in Azure. For this example, we can deploy each instance in a dedicated region, and the customer, in case of a failure, can fail over seamlessly to the second region without any downtime for the customers. That way, we ensured the high availability for our workloads, and our customers will always reach to the application without any downtime. We have a question: how we guarantee that this high availability will be always there? So, in other terms, we have a kind of contract between the customer and the service provider to guarantee this engagement. This is called the service level agreement or SLA. So let's take an example for the SLAs for virtual machines. Here we have different SLA level according to the disk that we use for our virtual machine. So for example, if we do add a HDD standard disk, this will have 95% of SLA. So usually on Azure, the SLAs are expressed in percentage. 95% means a downtime of 1 day, 12 hours, and 13 minutes, 25 seconds per month. However, if we upgrade to solid state disk standard SKU, we will be having 99.5%, which means 3 hours, 37 minutes, and 25 minutes of downtime per month. And if we upgrade to a premium solid state disk, this will give us 99.9%, which is the equivalent of 43 minutes and 28 seconds of downtime per month. As you can see here, different SKU for our disk means different engagement from the service provider for the uptime guaranteed for our virtual machine. So when we design our application, we need to take into consideration the resources that we are implementing, the type of the disk, for example, the type of the SKU of our database, the are we deploying our virtual machine in standalone mode or in a redundant mode in different data centers, in different availability zones or regions, and so on. All this depends on your design, on your perspective of the uptime for your application and the criticity of your workload. This is out of the box provided by the by Microsoft or Azure. Almost you tick a case, a checkbox when you deploy from the portal, or you include this in your infrastructure as code templates, and your infrastructure will be deployed according to the setup that you are looking for, and to reach the SLAs and the availability of your application. However, doing the same thing on premises, this will be requiring more uh, effort, more investment, and time to deploy. So, two things to take into considerations when you design your application is the SLAs, and more SLAs mean usually more cost, because upgrading the disk type will mean that you need to pay more for your disk. Let's explore the scalability, which is the ability to adjust resources to meet your needs. In other terms, imagine you have three instances of your application that is sized to serve like 10 people. If you have more people coming to your application, these three servers will not absorb the charge. And this will lead to a failure of your application. And you will lose some business, you will lose money and availability of your application. With the scalability in the cloud, you ensure that you have dynamic adjustment of your workload when more people comes to your application or more flow comes to your application. This will require no upfront cost, as the scalability will be ensured by the cloud provider itself. This is built-in features in most of the resources on the cloud. And for sure, you will pay only for what you consume. This is the pay as you go. And compared to the traditional IT, you don't need to buy more materials. You will only pay for the resources that will be used when you upscale your infrastructure or your instances to the higher SKU, or when you add more instances of your application. Only for the period of the scale, then you come back to your baseline of your application. And for the scalability, we have two types. We have the horizontal scale, which is the scale in or out, and we have the vertical scaling, which is the scale up and scale down. Let me explain for you. So imagine we have a client accessing an application. If we have more clients coming to your application, then we need to either do a vertical scaling, which is increasing the size of our instance. Imagine here we have 2 CPU, 4 GB of RAM. Then if we do a vertical scaling, which is the scaling up our application, we need to increase the size of our instance, like doubling the CPU or the RAM. However, if we do horizontal scaling, we need to increase the number of our instances, like keeping the same amount of CPU and RAM of your instance, and then multiplying the instances. So this is increasing the number, and it is called the scale out. So whether we scale out when we have more traffic coming to our application, and as soon as we don't have any more traffic, we will scaling in, so reducing the number of instances to come back to our regular deployment. If we scale up to 6 instances for 1 hour, just we will be just paying for 6 hours of our instance without the need of buying more materials. And the most important thing here to consider is the time to respond for this dynamic adjustment. As in cloud, this is immediately in couple of seconds or minutes, depending on your setup, will scale up. However, in traditional setup, you need to consider buying all these instances, putting them running 24/7, paying for cooling, electricity, and for materials as well, to patching, maintenance, and so on. But you will only use this when you scale up. However, in cloud, this is the pay as you go only when you need this stuff. Now, let's move on to reliability. To explain this, let's think about buying a new car. We often classify the best cars by their reliability ratio, which is based on how many times the car gets repaired, or the number of breakdowns and the cost to fix it. And last, its capacity to do what's expected from a car, which takes us to destination with comfort and peace of mind. The same reliability in the cloud computing refers to the ability of cloud system to consistently perform and deliver services as expected, without interruptions or failures. It encompasses various factors like the availability, durability, dependability, and quality, and so on. But in general, reliability is very tied to availability of cloud services and your data in general, as cloud often has strong fault tolerance capabilities like Azure redundancy of your services across different data centers, zones, or regions. Your data are consistently accessible and durable. Hosting your application in the cloud will protect you from dependencies like cooling, hardware, or multiple electricity issues and internet provider failure. With cloud, you ensure that you have the quality over the time. For example, if we take the storage, your data are by default replicated at least 3 times across different locations, and your data are consistently accessible in case of failure. But this will rely on your design as this cloud be replicated within the same data center or different DCs or another region. Now, let's discuss the predictability, which comes in two forms: performance and cost predictability. The first will be predictable performance. Azure uses monitored and managed environments to ensure predictable performance. As we choose the SKUs, for example, of our VM, we can estimate the number of requests that the infrastructure could support, and with the help of monitoring, we can predict when the application will require more resources to perform auto scale operation or to simply redirect traffic to a less stressed area. The second thing would be predictable pricing. Azure uses a pay as you go model. Unlike traditional IT, where surprises and over budgeting are common, the Azure pricing is transparent and controllable. Tools like the Azure pricing calculator allows businesses to estimate costs in advance. We can talk about cloud services without talking security, and Azure takes security seriously. The platform comes with multiple built-in layers of protection like the encryption at rest or in transit, with the ability to use your own encryption key. And we have various types of firewalls, like the Azure firewall or the usage of free services like the network security group or application security group. Second, the platform is highly secured thanks to various features like Evergreen, which will ensuring that your service will have always the latest available stable version of your application. Like for databases, you don't need anymore to upgrade the version of your SQL server. You will have always access to the latest version of your service. And thanks to automatic updates, your infrastructure will be always up to date with latest patches, and you will don't worry anymore about the security failures or the security issues like CVUs and so on. And lastly, Azure is compliant with global standards like GDPR and ISO 27 or ISO 9000 for the quality, and will ensure that your workloads are compliant with these regulations. And for the ease of management, Azure provides you with multiple dashboards that are built in into your portal, like the Azure Security Center, where you have the secure score of your entire infrastructure or with for a specific application, for example, or specific workloads like VMs, databases, and so on. And in this dashboard, you have the ability to get recommendations and even the way to correct and to resolve these failures or these non-conformities directly from the portal using a single push of a button, and everything will be properly set up for you, corrected, and you are always sure that your application is up to date, properly secured, and respecting all the standards and compliancy rules. Now we arrive at governance in Azure, which refers to the policies and rules businesses can set up to manage users, resources, and costs. For example, usage of templates allow you to deploy resources in a desired state configuration to meet business standards and regulations. This way, you can update your infrastructure easily to apply changes on all your footprint with ease with the use of templates. Also, the cloud like Azure, provides you with built-in features like auditing your information system using tags that helps you categorize your organization to detect non-compliant resources quickly. The third, reporting is so important in cloud services, and Azure provides you with multiple dashboards like compliance dashboard, FinOps, and cost analysis. And with this reporting, you can set up alerts to inform the administrators that they have to take actions or to validate actions, or simply you can configure automatic actions to resolve some failures or some updates, apply some patches, and so on. All these tools and built-in features will allow you to maintain a low risk of your infrastructure, ensuring that your infrastructure or your workloads are well and properly maintained in Azure, in cloud services, using built-in and provided tools from the service provider Microsoft Azure. Finally, we have the manageability. And in Azure, managing resources is simple and centralized. With cloud computing, IT teams can monitor, deploy, and manage resources with ease directly from the portal and programmatically using command lines like Azure CLI or PowerShell module. You have various dedicated dashboards like Azure Monitor and Application Insights to track the cost, performance, and receive alerts for issues as they arise, or Cost Management and Billing Center to keep cost understanding and avoid surprises by setting up budget alerts, for example. And to ensure business continuity, you can plan, track, and monitor your backup operations from the backup center to cover all your footprint, to have to manage your business continuity and disaster recovery plan. All these actions could be operated directly from the portal using policies or programmatically using command line or infrastructure as code with your preferred scripting tools like PowerShell, Bicep, or Terraform. Now that we have learned a lot of concepts, let's check our knowledge. The first question, which type of scaling involves adding or removing resources, such as virtual machines or containers to meet demand? The vertical scaling, the horizontal scaling, or the direct scaling? The keywords here, adding or removing resources. So we need to add more units or more resources. So this is the horizontal scaling. The second question, what is characterized as the ability of a system to recover from failures and continue to function? So if we have a failure, our system will continue to work. So, and here, this is the reliability. Let's check our answers. And as you can see, our answers are correct. In our next video, we will delve deeper into Azure's core services. So stay tuned. Don't forget to like this video and subscribe to my channel for more Azure fundamentals training. If you have any questions or topics you'd like me to cover, please leave a comment below. Until next time, happy learning. Bye bye.